Hello everyone, this is Professor DePaulo welcoming you to Psych 220 walkthroughs. And right now I'm going to be talking about how to compute measures of central tendency, the mean, median, and mode, and also how to compute measures of dispersion, which is the range, the variance, and the standard deviation. So I have a variable called age, and I have a bunch of values here. So I'm going to first start out by writing them out lengthwise because I prefer to do it that way. So these are my x values here. So step one, I'm going to write them all out. So x, 8, and of course my writing is not the best with the tablet. It's not the best writing in any format, to be honest with you. My handwriting is pretty poor. Eight, 9, and 12. Okay, so that's what we have so far. Okay, so now in order to find the mean, so mean is equal to sum of x divided by n here. So to find the sum of x, I will cheat and use r. So it's 165. Rather than do it in my head, I can just do it in r. Divide by n. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 is my n. And that's going to be 11. I don't need r for that. 11 is my answer for the mean. Now for the median, I want to find the position of the median. So the median position is n plus 1 divided by 2. So n is 15 here, so it's 15 plus 1 divided by 2. So the position of the median is 16 over 2, which is 8. So I have to find the 8th one, but I have to put it in order first. So let's put this in order. So in order, it's going to be starting with 7. So I have 7. I have 1, 2, 3, 8s, I believe. I have how many 9s? I have 2 9s. How many 10s do I have? Looks like 1, 2 10s. 11s, I have 1, 2 11s. 12s, I have 1, 2 12s. 13s don't have any. 14s don't have any. 15s, looks like I have 1. 16s don't have any. 17s, looks like I have 1. 18s, looks like I have 1. No, nothing greater than 18 here. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Okay, so that looks like I'm in order. Just double check, obviously, and go through it here to see what you have here. So 7. How many 8s do I have? 3 8s. I'm going to cross out here just to make sure. Any more 8s? No. 9s. 10s. 1 10, 2 10s. Okay. 11s. Looks like 2 11s. 12s. 2 12s. 13s, no. 14s, no. 15. 17 and 18. That looks great. So now count 8, starting at the low end. 1, 2, 3, 4, 5, 6, 7, 8. So it's this one. This is the 8th one. So the median is equal to 10. So you got to put the numbers in order from low to high before you compute the median. And now to do the mode, the most frequent value. I can just look at what I have here. I have 3/8, and that's it. So it's got to be 8. Since I have 3/8. And of course, when you can, you check. I use R to check things when I can, because obviously you can make mistakes. So the median's 10. Mode is going to be hard to check because it tells me numeric. It's telling me the mode of the data point, not the actual mode of the data set. But we can check easily that it's 8. There's a program you could write for mode if you really need to look at it, but you got to write it out, and it's not easy to write, so don't really need it for here. So now let's look at, so I want to compute variance, right? So variance, range is next, sorry. Did median mode. Let's do range. Range is highest minus lowest. Highest is going to be 18. Lowest is going to be 7, so the range is 11. And these are very easy points here for the exam. Now for the more difficult one, variance. Variance of a sample is s squared. So that's equal to either the sum of x squared minus the sum of x quantity squared over n all over n minus 1. That's minus. Or sum of x minus m quantity squared all over n minus 1. So one of these two formulas, I'll do both. But start with the one on the left here. So I'm going to find the x squared values. So these I can do in my head pretty much. I think this is 324. I'll check it. I think this is 389. I'll check it. So I'm doing it in my head, but I'm going to check it in a minute in R. Just like I always do. Because I could use a calculator, but why use a calculator when I have R, which is much better than a calculator. So let's look at age squared. So those are my squares. And I will just double check it. I'm just rearranging this here so I can look at it. 64, 81, 100, 225, 324, 280. Oh, 289. I got that one wrong. I put 389. So it's good to always check it with either a calculator or in R. What's going on here? So this is going to be 289. 289, 144, 121, 49, 64, 100, 121, 64, 81, 144. Good. So now I'm going to sum up both the X table and I'm going to sum up both of these tables here. So I'm just moving this here. So I'm going to have a sum of X. And we can do that here. Sum of age, 165. And then I want a sum of x squared here too. So I could do sum of age squared. 1971. So obviously it's going to take you a little longer to do that on a calculator, but you get the same results. Okay, so now that I'm done with that, I can go back to full screen this. Let's move this into the picture a bit. And let's do x minus m. So actually, let me finish the first one here. This is the computational method. So sum of x squared, I have that. That's right here. It's 1971. Minus sum of x, which is 165. Quantity squared, this is 15. All over 14. So let's simplify that. 1971 minus 165 squared over 15. I obviously can't do that in my head. 165 squared, 27,225. Over 15, all over 14. Let's simplify that. 1971 minus 27,225. 27,225 divided by 15. That gives me 1815. Let's go back to here. 1815. All over 14. Let me just move that up a bit. So that, I probably do that in my head, but I'm going to be lazy and use R here. 1971 minus 1815. 156. I like doing things on my head when I can because it's good to keep your mind moving. You know, we're so reliant on technology for everything. We want to exercise our brain a bit if we can. And then 156 over 14 is 14. No, actually it's not. It's 11.14. 11 point, I rounded 2 decimals. 11.14 rounded. That is my variance. To find my standard deviation, just take the square root of that. Gives me 3.38 rounded. That's my standard deviation. And I'm checking it with R, so that's obviously correct. And that's obviously correct. So that problem is done. Okay, so that's how we do that. And look, use your calculator. Your calculator is a little harder than R is for me. I mean, R is like the no-brainer for doing this stuff. You could do it in Excel too, if you wanted to. You can do it very easily in Excel. And if you want to do it in Excel, let's see if I can show that fast. I gotta put my data in here. 8, 9, 10, 15, 18. 8, 9, 10, 15, 18, 17, 12, 11, 7, 8. Uh, 10, 11, 8, 9, 12. And then I would just do sum here. Equal, always have to put equal sign first to get the answer. Sum of this. I just click and drag. It's not letting me calculate. Sum of all of this. So you got to put the parenthesis there. 165. Then if I wanted to do mean, so that's 165. If I want to do mean, put equal mean. Put parentheses. Don't do the 165, obviously. Just do the data points. Don't do the 165. And parentheses. It's not giving me mean. Oh. Why is it not giving me mean for? Saying name for some reason. Oh, because I'm not picking mean right. I gotta use okay, so Excel uses average. Forgot. I gotta use average instead of mean because it's got geometric mean and harmonic mean. So for the arithmetic mean, it uses average. That's why it's giving me the error. So I have to do average to find the mean. So mean is 11, right? I think variance is the same. Hold on, equals. Let's see what it's got for variance. It's got variance here. Let's see. Yep, there's the variance, 11.14, and it's got standard deviation here. So you got to just type in the only thing that was different was average. So instead of mean, you had to type in average. So equals, let's see, standard deviation. How do I spell it? You can always look it up. You can always Google it. I'm just being lazy and not just trying to bring it off the menu here. So let's do that. And there's your standard deviation. So you can always do it in Excel too. I do it in R because it's just so much more robust than Excel. But you can do these basic things in Excel also. If you can't remember all the commands, remember you have to start with an equal sign, and then you have to have a parentheses after the actual command that you're using. And then I just drag it down through the list of data points, right? If you don't know, Google it. I mean, I Google all the time. I Google constantly. Like, especially when I'm doing data analysis, because there's no way you can remember everything for every program. So just Google, and you'll get the answer right away. And you'll learn how to use it. So by Googling, and then you practice it, and Excel is a useful thing to know. Not for data analysis per se, but for just, structuring the data and bringing it into like either R or SPSS or SAS or something else. So let's go back. So we did all of this in R. We did all of this in Excel now. I want to do it the long way, the definition or conceptual formula. This one, x minus m over. So let's do that. Variance is sum of x minus m, so I need to have an x minus m column. And I also want an x minus m squared column. Remember that we want to use the squared deviations because the sum of the deviation scores, this column, x minus m, the deviation scores, each score minus the mean. The sum of this column is always going to be 0, so I want to use the squared of the deviation scores. So my mean here I already found before, up here. Mean was 11. Okay, so mean was 11. So we're do 8 minus 11. I'm not going to write the minus, but this is what we'd be doing. 8 minus 11 is negative 3. So I'm just going to write the answer just because it's easier. So let me get rid of that. So 8 minus 11 is negative 3. 9 minus 11, negative 2. 10 minus 11, negative 1. So I'm just subtracting 11 from each of these. And this is pretty easy to do. This column will add up to 0, so double check. Negative 5, negative 6, negative 2, 5, 11, 12, 8, 5, 4, 1, negative 1, 0. So it adds up to 0. Now square each of these. And I can always check this in R also. The deviation scores and stuff. You could do it in Excel also. Remember that these values in the x minus m, these are the deviation score squared. These are always going to be non-negative, so it's 0 and positive only. Non-negative values. Can't have a negative variance. At least in this course you can. Theoretically you can in certain circumstances, but not for this course. Now we're going to sum this up. This is the sum of the squared deviations. This is the sum of squares, right? So x minus m squared, if I sum this up, so this numerator here is also known as the sum of squares, or the sum of the square deviation scores. 13, 14, 30, 79, 115, 116, 132, 141, 142, 151, 155, 156. And that's correct, because that's what the last one was. So this is 156 over n minus 1 is 14. 156 over 14 is 11.14. This is what I got previously. And then the square root of that is 3.38 rounded. So I've done it both ways. Now remember that if you have a whole number, if you have an integer as the mean, then the second way, this deviation scoring method, is probably easier. If you do not, if you have a decimal as a mean, then the first way, the computational method, is probably easier. So take that in mind. Now I don't care which way you do it. You could do it either way. But I find that the deviation score method that we just did is easier with whole numbers as the means. Less computation, the numbers are smaller. Versus if you have decimals, then this is going to be a mess. If you have decimal as your mean, a number with a decimal point, you want to use the first method, the computational method. And that's it. So we've done this both in R, SPSS, and manually here. So hopefully that helps. And bye for now.